Hello everyone. In this video again we have come up with a fairly interesting question, basically with the system of linear equations. So let's take a look. Consider the following three linear equations of four unknowns being x1, x2, x3 and x4, and the equations being x1 plus x2 plus x3 plus x4 equal to 4, x1 plus 2x2 plus 3x3 plus 4x4 equal to 5, and x1 plus 3x3 plus 5x3 3x2 plus 5x3 plus kx4 equal to 5. If the system has no solution, then we need to find the value of k. So let's take a look. So the system of equations are x1 plus x2 plus x3 plus x4 equal to 4, x1 plus 2x2 plus 3x3 plus 4x4 equal to 5, and finally x1 plus 3x2 plus 5x3 plus kx4 equal to 5. Okay, so now what we can do is that we can basically show this in the form of an argumented matrix. So argumented matrix form is, so let me just draw the argumented matrix form. That would be, so the coefficient is 1 here, so we'll put 1 followed by another 1 1 1 1, so 1 1 1 1. So basically we'll use this ones. Again here 1 2 3 and 4. So 1 2 3 4, subsequently 1 3 5 and k. So 1 3 5 and k. Okay, and subsequently this is 4 5 5 4 5 5. Okay, so this is what we have over here. Now what we can do is we can perform a few operations in general. So the first operation on this particular matrix would be so R2 equal to R2 minus R1, and another one would be R3 equal to R3 minus R1. Okay, so we can actually go, how we can go about this. So we have a matrix, so R1 basically remains the same, 1 1. R2 would be R2 minus 1, so 1 minus 1, so let me just highlight the 1 minus 1, so this one minus this one, so it would give us 0. 2 minus 1, this 2 minus this one would give us 1. This 3 minus 1 would give us 2, and 4 minus 1 would simply give us 3. Similarly, R3 also, R3 minus 1, so 1 minus 1 again would give us 0. 3 minus 1 would again give us 2. 5 minus 1 would give us 4, and k minus 1 would simply give us k minus 1. Alright, and similarly for this as well, 5 minus 4, 4 would remain same, so this would come up to be 1 and this would come up to be 1. Alright, so now again we have to perform one more operation so that we can actually go ahead for the same. So now our next operation on this would be this here. So R3 would be equal to R3 minus twice R2. Okay, just let me write this in properly. Twice R2. So how would our resultant matrix basically look like? It would be something. R1 would remain the same. R2 also would remain the same. 4. But R3 would be R3 minus twice R1. So R3 here, no, R3 minus twice R2. So 0 minus 2 R2 basically give us 0. Minus 2 R2. 1 minus 2 R2. So basically 2, this will give us 2 minus 2 into 1, again a 0. Again 4 and this, so 4 minus 2 into 2, again a 0. And again k minus 1 minus 2 into 3, this will give us k minus 7. K minus 7. And for this one, here will be 4 and 1 would remain the same, and this will again give us 0 because 1 no, it will give us minus 1, my bad. 1 minus 2 into 1 equal to minus 1. Sorry. Minus 1. Okay. So this is our final form of the matrix. So now, having got us for no solution, k minus 7 must be equal to 0. So therefore k should be equal to 7, which is a final answer. So hopefully this thing is clear to you. So how we arrived at the conclusion. Kindly go through the problem in general, how we have basically implemented the augmented matrix form while solving this particular question in general, and how by applying various computation on the matrix itself, we basically can figure out the answer of the given problem. So hopefully all the steps pertaining to the problem is clear to you, how we arrived. So with that said, I'm signing out. Thank you so much.